Hello viewers, in today's class we are going to discuss one important application of Lagrange's mean value theorem in number theory, right? So here we have a very important problem, and the problem goes like this. We are given any two real numbers a and b, right? Such that the number a is less than b, right? So here we are given any two real numbers a and b such that a is less than b. Then we have to show that there exists a real number c between a and b such that c square is equal to 1 over 3 times a square plus ab plus b square, right? So by the method of Lagrange's mean value theorem, we'll solve this problem, right? So let us start. So viewers, before going through this problem, let us quickly revisit the statement of Lagrange's mean value theorem, right? So Lagrange's mean value theorem says that if we have a function, say y of f of x, y is equal to f of x, and it is defined in some interval, say a comma b, right? And if this function satisfies the conditions, that is the function f of x is continuous in the closed interval a comma b, and the same function f of x is differentiable or derivable, right? So if the function f of x is also differentiable in the open interval a comma b, then Lagrange's mean value theorem says that there must exist some point c belonging to this interval, that is a comma b, such that f prime of c must be equal to the quotient of f of b minus f of a divided by b minus a, right? So Lagrange's mean value theorem says that if we have a function y is equal to f of x and it is defined in some domain that is given by this interval a comma b, and this function is continuous in the closed interval a comma b and differentiable, or this function is having a derivative at each point in the open interval a comma b, then there must exist a point c between a and b such that the derivative of this function at this point c is equal to f of b minus f of a divided by b minus a, right? So we'll utilize this statement to solve this problem. So here what we will do, we'll first assume an appropriate function, right? So we have here y is equal to f of x, right? So here let us assume a function f of x is equal to x cube, right? So in order to solve this problem, let us assume a cubic function, right? So a cubic function is to be assumed here to solve this problem, and let us define this function in the interval a comma b, right, where a is less than b, right? So once we have assumed this function f of x, let us verify the conditions of Lagrange's mean value theorem to this function, right? Now see, this is being a polynomial function, right? So f of x is equal to x cube is a polynomial function, and we know that all polynomial functions are continuous, right, in the given interval. So polynomial function are continuous in this interval. Here the interval is a comma b, right? So x cube is a polynomial function, right? Okay, now if we differentiate this function, we'll get f prime of x that is equal to the derivative of x cube, and this is simply 3x square, right? And we see that the derivative is again a polynomial function, right? So here we have a quadratic function, right? And we can easily see that this function has a derivative at each point in the interval, that is the open interval a comma b, right? So the first two conditions of Lagrange's mean value theorem are satisfied by our function, which is a cubic function. F of x is equal to x cube, right? So now this Lagrange's theorem says that there must exist some point c belonging to the interval a comma b, such that the derivative of this function f of x at this point, right, that is at x is equal to c, must be equal to f of b minus f of a divided by b minus a, right? Now f prime of c can be obtained from here because f prime of x is 3x square, right? So if we replace x by c, we'll get f prime of c is equal to 3c square, right? And here we can substitute f prime of c. So we have 3c square is equal to f of b, right? F of b can be obtained by replacing x by b. So we have simply b cube, and here f of a can be obtained by replacing x by a. So here we have a cube, right? And in the denominator we have b minus a, right? So now here we have a simple algebraic expression, right? And in the numerator we see that we have a well-known identity, that is x cube minus y cube, right? So this is a famous identity in the um, college level algebra. So x cube minus y cube is x minus y, and here we have x square plus xy plus y square, right? So here we can simply write 3c square is equal to b minus a, and here we have b square plus ab plus a square divided by b minus a, right? Now see, this factor get cancelled here, so we are left with simply b square plus ab plus a square, right? So now 3c square is equal to b square plus ab plus a square. So c square can be written as 1 over 3, dividing this term by 3. We have 1 over 3 times b square plus ab plus a square, right? So this is the desired result, which can also be written as here interchanging a square and b square. So we have a square plus ab plus b square divided by 3, right? So this is the desired result, right? So viewers, this is how by making use of Lagrange's mean value theorem we can solve these type of problems.